Hello and welcome to one more brief edition before we move the pilot radio up to the 10-buck test bench to do the final alignment of the IF and the RF sections using our vintage or period correct test equipment. Before I move this up there and put power on it, I want to go through, of course, and check all the resistance readings, the resistance chart that's supplied here in the Sam's PhotoFax. Because I've been soldering, desoldering, I could have made a mistake. I could have generated a short circuit. Some of the solder balls that fell off could have fallen between two pin sockets. That could be disastrous. So just as a sanity check, we go through and we do the resistance readings to find out if, everything looks fairly normal. Now, I've said this before, and I'm going to be saying it again, I'm sure in the future. Before you do any voltage measurements or any resistance measurements in these sets, you have to come down here and read the notes. And it says voltage measurements are at 20,000 ohms per volt. AC voltage is measured at 1,000 ohms per volt. In other words, they're using a VOM. A VOM very similar to my triplet 630 over here. That is important. Important, depends on what part of the country you come from. Using a VTVM or a high impedance modern meter is going to give you false readings. Now, I've done several videos on this. You can go back and find my videos on which which meter to use, why it's important to use the correct meter, and the false readings you can get. And I'm going to demonstrate that here. Let's see, where's an easy one to get to? 1, 2, 3. Okay. On the 12SK7, which is the first IF tube right here, on the 12SK7 on pin 6, they have a measurement of 40,000 ohms, 40K ohms. And this is the screen grid on the 12SK7, which goes down to the power supply. There's a lot of filter capacitors in that circuit. If you try to use a modern meter, you're going to get false readings. Now, I have several meters tied into the common DC bus here. This is not chassis ground. This is B-. It's isolated from the chassis. Over here, let's see if we can get everything in frame. I think so. You can probably see the blinking lights right up here on this. This is a fluke, and that's about a 1 gig ohm class meter instead of a 20,000 ohms per volt meter. Now, I'm going to use the fluke. Let me make sure I get the correct probe here. Okay, here's my ground. Bear with me. Okay, I'm going to go to pin 6 and see if I get anything approaching 40,000 ohms. That's reading infinity. It's telling me absolutely nothing useful. Oh, now it says 18 megohms, 17 megohms, 16 megohms, 15 megohms. Gee, that's nowhere near 40,000 ohms. Let's try the one below it. We have a Keithley, which is about an 11 megohm class meter, like a VTVM would be, or a FETVOM would be, about 11 megohms input impedance. So let's take a look at what the Keithley gives me on the same. Let's make sure. Do we have a ground connection? Have I got the right lead? Yes, that lead's connected here. Okay, I'm going to check this same pin. The Keithley's not showing me anything at all. Let's go to the ground here. Okay, we see we have continuity. If I can get steady on the connection here. It says 4 ohms. It's a little less than that. That's just the leads. I haven't zeroed them out. Oh, that says 41 megohms, 39 megohms. Again, 34. It's jumping all around. I hope you can see that on the camera over there on that meter. No meaningful readings whatsoever. Okay, we'll go up to something a little more vintage. Let's see, up there, right here, can you see that one? That's a Heathkit. That's an 11 megohm, the equivalent of a VTVM. That one happens to be an FET VOM, solid state VOM, volt ohm milliamp meter, but it's the same thing as a VTVM would give you. Same impedance. And I've got to find the ground here. We'll connect this meter. And just to show you it's working, I hope you can see. Let's see. There we go. We should be able to. Is the light in the way? Nope, you can see it. Okay. You can see the needle swing to 0 and come back up. I'm going to go on pin 6. And oh, there's a little bit of a charge there from the other 2 meters having been on it. Let's hold it on there until that dissipates. I might have to discharge that with a screwdriver. Bear with me. Okay, we're going to ground that. Remember, we're looking for 40,000 ohms. And the meter is settling back, and right now it's basically reading nothing. Absolutely nothing. Okay, I'm going to go to my trusty triplet. All right, VOM. This piece, we're doing this as a reshoot because I realized the first time I filmed, as I was editing this, I realized the first time I filmed it or videoed it that the meter was not anywhere near in frame for this part. Come on, get on there. Behave. Very good. So we're back. We're going to put this down on 1K. And it probably won't read very long here because the cap and the circuit, ow, just stabbed myself. The caps and the circuit are going to charge up pretty quickly, but we're on R times 1K. Let's check the 0 of the meter, a little bit on the high side. That's the one downside to using these, is you have to change ranges and re-zero the meter. But at least your final result will be correct. Alrighty. Let's go down here, and it should be around 40. And there it was. It went up to about 50, but the cap was charging. It fell back down. That's the result we're trying to find. Now we'll go up to the times 100 scale, 100K scale. And we should come up here to somewhere around 40. Now the same thing's going to happen. The caps are going to start charging, but we should get an initial reading pretty close to what we're supposed to have. And there it is. 40,000 ohms, 50, 60, 70. But we started out at 40,000 ohms, which is what the schematic says the value should be. That's important that you use the correct meter. Now back to the original video. So there you have it. There's one very important reason to use the correct meter as listed in the parts list or in the schematic so that you get the correct results. You're just going to get a lot of misleading readings using modern voltmeters when they tell you to use a 20,000 ohm per volt class meter to take your readings. I'll also be doing voltage measurements on this when we get it upstairs in the $10 test bench, or the $10 test bench, excuse me. Don't even know what I have. I will again be using one of my triplet 20,000 ohms per volt meters. And this says right on here, I get it the light right here, ohms per volt, 20,000 ohms per volt DC, 5,000 AC. Since we're going to be doing DC measurements, we'll be fine with that, even though they call for a 1,000 ohms per volt meter for the AC readings. Remember, use the meter that's specified, or a class meter that's specified in the instructions, and you'll get the correct readings. I've been through the radio. Everything's within 15-20% of what the schematic says it should be. Oh, one more thing. You may or may not have noticed I have the antenna laying here, and over here in the background we have the speaker, the electrodynamic speaker. They are both plugged into the set. The notes will also tell you down here to where is it? Put it on the AM. Somewhere in here. Gains measured. Oh, note voltage and resistance readings taken in standard broadcast position. That's important. You will not get the correct results in the RF section in the front unless it's in the broadcast position and unless the antenna is plugged in, because this antenna loop becomes part of the resistance readings in the RF amplifier. Likewise over here, the field coil is what makes the connection between the rectifier and the rest of the B plus and B minus circuits. You have to have the speaker plugged in. Also, the voice coil has to be plugged in. So plug in the speaker, plug in the antenna before you make your measurements. Follow the instructions. Very, very important. Something on SAMs you don't see on a lot of the schematics. This has gain per stage, and it lists 600 kilocycles. It's 5 times for the RF amplifier, 25 times going into the converter, so on and so forth down the line. Down here in the audio section, it's 400 hertz. The preamp is a 40x, and the power amp is 15x times amplification. That can be useful when you're trying to troubleshoot why a radio is weak. If you only had 5x on the preamp, there's your problem. If it's reading 32x, it's probably fine. But that gives you a relative indication of what kind of gain per stage you should have. So, that's it for now. Short and sweet. We'll be moving up to the 10-buck test bench. The next time you see this, we'll be turning it on for the first time in front of you. If the smoke leaks out, you get to laugh at me. If it doesn't, I get to chuckle that I did another fine repair job. Anyway, I shouldn't get too cocky. Something bad always happens when I get cocky. See you later. See you soon. Bye.